When we talk about y goes directly with x, think about an example. And this is something very directly. Think about you and kids going to the show. What, $58 right now for a ticket? Well, if one of you goes, how much are you going to spend? You go by yourself. $8. Two of you go, how much are you going to have to spend? Three. And 32, and then 40, and so on, because you're multiplying that constant, because the price of the ticket is not going to change. The number of people that are going is going to change. So if your number of people increases, your x, okay, then your y is going to increase. Or think about if you're getting gas, putting gas in the car. Okay, if you go to fill it up, it's what, $2.91, $2.92 right now? That amount is going to be the same for every gallon you get. It doesn't matter if you get 2, or if you get 5, if you get 10, if you get 20. You're multiplying that $2.91 times everything. That is your constant of variation. That amount that is the set rate for that item or that thing is going to be your constant of variation. So when we put this on here, I want you to write up here at the top. It says if y varies directly with x. That means that y over x equals k. K is the constant of variation. It's your rate that's not going to be changing. Another way that we can write this is we can say that y is equal to our constant times x. That's kind of what we were saying when we were talking about the ticket. 2 people go, multiply it times 8. 3 people go, times 8. It's going to change the total amount. If you multiply both sides by x, we've been doing a lot of rearranging. It's the same equation. Okay, so it says y varies directly as x. This is what it's talking about. We can write it in either way. Because if you have 2 out of 3 variables, letters, you can find the other one. So we do a couple of these, just as an example. Here we have x and we have k, but we don't have y. I don't care which one you use. You say y over x has to equal 1/3. Well, if you do it that way, you have a proportion. Okay, we've talked about solving those. Or you can do it this way. Y equals 9 times 1/3. Which, by the way, is how you would solve that one. What's 9 times 1/3? You got your calculators. You need to stick in there. 3. So we have 3 for our y. Look at number 6 down here. On number 6, you're given y and x. You're looking for your constant. So, fill it in. Y over x has to equal k. And I think that's probably the easiest way to do it, because you say y varies directly with x, you have y over x. So, what's -15 divided by -6? Something.
-15 divided by what?
-6. Okay? You should get 2.5, you're dividing.
Oh.
Get 2.5 is k. So what that means is, whatever x is, you're multiplying by 2.5. So we still have independent, because you can change x, and many people can do something, it may go on the gas, whatever. Dependent is your result, your y. This is our rate. So those word problems we did, we got initial plus rate times quantity. This is rate. Okay, I'm going to skip the table for just a second because I want to look down at the graph. Because these are easy. Tell when the graph has direct variation. Write this underneath it. Must go through 0, 0. If yes, give the constant of variation. This is your slope, because slope is rate of change. So if the graph is direct variation, All you have to do is look at it. It has to go through 0, 0 because if none of you go to the show, do you spend money on tickets? No. If you don't put any gas in your car, do you spend money on gas? No. So your starting point is 0 every time. So number 10, is this direct variation? Yep. Goes to the origin. So yes, it's direct variation. We counted slope the other day. What's the slope of that line? There's a constant of variation up 1 over 4. In our equation, y equals 1/4 x. We don't have a plus anything because it's 0. So that is an equation of direct variation. What about 11? Yes or no?
No.
No. Can I write an equation?
Yes.
Yes. Where's it cross the y-axis?
Two.
So it crosses at 2. What's your slope? I mean, is it down 2? Over 2? What's 2 divided by 2? 1. So we're going down 1 over 1 basically each time. That's your constant of variation. But it starts at 2. Okay? Maybe you're buying coffee every day and you have $2 and you spend $1 each day. Well, how many days can you buy it? 2. Okay? Because you're spending it each time. What about 12? Yes or no?
Yes.
Yes. Because right here it tells us it goes to the origin. Well, what's our slope? Is it positive or negative?
Negative.
Going down, it's negative. So your constant variation is -1. Your equation is simply y equals -1x or negative x. Start from the left side of your graph. We always read a graph like you read a book, from left to right. If your line is rising as you go left to right, it's positive. You're kind of up and over. Everything's positive. If from left to right your line is falling, think about a plane descending. Starts up here. If it's descending, it's negative. Okay, so that's a graph and that's an equation. Look at our table. One's in the middle. Just tell if it's direct variation. If yes, give the constant in the equation. Which one goes on top, y or x? Y. Let's tell your page. Direct variation, y over x. Well, let's do it. Let's divide them. What's 10 divided by 1? 10. What's 9 divided by 4? 2 point something. 2.25? Are those the same? Nope. Not direct variation. It's like the ones we did with slope before, the linear function. That's a linear function. Those are not the same. Not gonna work. What's 15 divided by 75? Okay, 0.2. What's 10 divided by 50? 0.2. What's 5 divided by 25? 0.2. Is this direct variation? Yes. And our constant of variation is 0.2. Or, if we were to write it in an equation form with slope, what's 5 over 25 reduced to? 1/5, which is the same thing as 0.2. So I can write that equation. Y equals 1/5 x, and it doesn't have a y-intercept. Well, it does have a y-intercept at 0, so we don't have to write it. So your constant of variation is going to be the slope that you put into a y equals equation. It's the rate of change that something is varying by. And it's got to be the same all the way through. It's one of those examples in your head that you can think of, you know, the tickets or the gas or maybe the amount that you have to pay extra if you go over a minute, okay, on your data stuff. whatever it happens to be. Okay, on the back has the word problems, and so what I want you to do is to look at those, think about you in here, and fit them into one of those equations, and then solve.